Hi, I'm Neel.
Hi, I'm Alisen.
Here's our circuit diagram, and here's a shot of our circuit. As you can see, we are supplying 15 volts in through the 10K potentiometer, and then we are supplying that into the positive input. And from the negative input side, on the emitter side, we have a 1 kilo ohm resistor connected to a 15 volt input, and then we use the ammeter to measure the collector current. So as you can see from our IV plot, as we increase Vn, IE decreases. This is because Vn is equal to Ve, and IE is equal to the collector current, which equals 15 minus Ve over 1 kilo ohm. So if we increase Vn, we increase Ve, and the current will over time decrease as for higher values of Vn.
This is our circuit for part B, and this is our input waveform. We input a 1 kilohertz triangle waveform of amplitude 2 volts offset 2, and this is because the Digilent can't supply voltages over 5 volts. So to correct that, we use the op-amp with the gain of 2.5 to create a 10 volt peak-to-peak positive triangular waveform. This is our Schmitt trigger circuit. The Schmitt trigger circuit takes a signal and turns it into a digital signal with on and off. To switch from on to off and on to on, the signal must pass first through the low, then to the high thresholds to turn on, and from the high to the low threshold to turn off. Our low and high threshold voltages are 3 volts and 7 volts respectively. Here's the input and output waveforms of the Schmitt trigger. Here we have the yellow input, and then it turns on
It turns on and off with respect to the threshold voltages of 3 volts and then 7 volts. This is our complete VCO circuit. As you can see here, we have our current source with the potentiometer. Then over here we have the Schmitt trigger. And then over here we have the current mirror. Here we have Vin versus output frequency. As we increase Vin, you can see the output frequency decreases. This is because as we increase Vin, over here on the negative input of the op-amp and the current source, less current is being drawn. As a result, less of the current reaches the current source, and over here you can see that the transistor Q3 and Q4, the rate at which they go into saturation or cutoff decrease as we increase this Vn value in the beginning. This is why the output frequency starts to drop like the further and further we increase the Vn values.